sankha ma columns amene akhala ma factors ndi kusankha ma columns amene akhala ma variables. Tsopano part 2 tibwera ndi part yopanga analyze data. Choyambirira ndi data imene apapayi kupita ku ngati ufuna muone summary ya data yakungona summary ya data yo, go to summary statistics, ona summary ya growth, summary ya survival, kenako kuti muone mufuna muone ngati ma minimum nangasi awana ali ma values. That's why it's the data made for all ma summary ma factors amaka predefined, so ngaone minimum maximum ema values oti ena ndi ma weights ngati semusa ngati ena china carrots. Again simngone mean yolongosoka ine yako percentage inafuna muone summary chifukwa ndi ma values oti napanga predefine. Yeah, if you want to see more statistics on this, on standard error, minungapangire kumano apa. So far we don't want that. Talo sama variables atwo kapangalani kona summary awata pangalani, when you go to window kona output window kona summary ya data atwo kanimene ya identifiers my value ya 18 missing 0 ndenge akauti pina pake data mwala kusamala usedwe missing pa makhala value. That's when you see kuti nda kusajani ndi conservative. Again, if you want to see the minimum, mean, maximum, number of values, this means this is so on growth and survival. That's again the summary is growth in the survival. About the one also joint. Ndetibwe data by going to my books data today. Then gonna minibali apapamu mainly data ngati analysis yake makhala in one way or another chifukwa makhala kupanga kulenga ndi the experiment in question na ndi apapamu mene zilimu ndi treatment yaikulu ina alcohol percentage and alcohol percentage timaona kuti zizimera bwanji or zimera zingati zipanga survey zingati kulenga ndi experiment iyi. And with this data, tipita pa stats, when you go to analysis of variance 1 and 2 way, this is one way. My variance tisanka tunadonia growth be replicate and we'll do use a core percentages of treatment. Tisana bangirani, go to options, you check the CV to see the coefficients of variation, the variabilities around the mean. We check the significant differences. Go for multiple comparisons even. Kusanka test mean of no sheet. Thereby you have to be very careful. If you have my treatment order less than 5, if you have less than 5 treatments, we use Fisher's protected LCLSD. If you have more than that, use this unprotected. But if you have more than 10 treatments in 2 ANOVA, we use Duncan treatment. So here, for my treatments are two, we have your 70, we have your 80, we have your 100. Use a Fisher's protected LSD. It works well with descending. Say okay. We're all good here. We check the ANOVA table, we see information, we see the means, we see the probability, and returning that the experiment is significant or not. The rest is my differences at 5%. Most agricultural experiments are the least significant difference is measured at 5% confidence level. Whereas the experiments, the studies, science, the LSD, the measure at as low as 1% confidence level. Say yes. Ndababa mindabangiramu. We run. Tikapangani. We again go to output window to see means that look here as on First table ndya analysis of variance. Ndi apa tikuona kuti f value yatibwesera less than 0.01, which means this study was highly significant. The differences between the means was highly significant. The table of means, we see the grand mean across the treatments. We see the mean on each treatment, like 70% had 8. The number growth of lubricant here out of 10, because the total is 10. We can check. The total expense is 10. Yes. So per 70% you had 8, per 80% you had 5, and per 100% you had 1.5, sorry, and 100% you had 0.6. The least significant difference between my value 0 and the 0.7, the coefficients of variation, the 16%. If you have a coefficient of variation which is less than 30%, is ideal for your experiment. Kwambiri chifutimaka kuti mamini yako sali variable kwambiri across the mean, the grand mean. Whereas if you have a CV above 40%, ndikuti your data inapangidwa affect ndi some external factors ngati kakhala ya mulabu muona ngati ma diseases ndoti muna panapena pake effect nabwaye kuli chifukwa cha environment muna external contamination sinaitike kwambiri muna plant inake ambali nabwesamo other diseases or anything what is mafuna mpange measure koma zinangochitika in your treatment. And pamusi pati mona ma mean across the treatments. Ndi maleta zalikuwa amakama differences akawati maleta zakusiyana ndi kuti difference ya maminiyo is greater than the least significant difference paka kusiyana. If you had a 2 here, the 2 minus 1.5 is less than this, means the means will not be separated, they will have the same number. That's the whole meaning. So amasiyana manambalawa chifoti mamini yawo makauti yakupangidwa separate because of the least significant difference. Ndiye ingono chenchima. The CV tafotokoza kufunikira kwake. Then my mean anything tafotokoza kufunikira kwake. Analysis yake pa wanu ya ANOVA ndi imeneyi titaso kupita pa variety ina ndi kuika ka survival ndo pangaran. We see the very same things. They are differentiated at a CV of 15%, and the rest is 6%, 6.99%. These are the means, and it is highly significant as well. I hope we're on the same boat. Kutengera ndi one analysis of variance, ndi treatment ochepekera 5. Please note kuti kapita kuma options multiple comparisons. This part tauzina yavezi got by babel. Don't panic. What you have to do is just go to tools, more options, menus. If this part is not checked, more options, that option goes away. But if you check this part and again see this option comes back, there. Please note, if you have less than 5 treatments, we use Fisher protected LSD. More than that is 10 protected one. If you have 2A, more than 10 treatments, we use Duncan. 2K is used when you're trying to make comparisons among means, not necessarily separating them, but making comparisons. So far, so good. I think on analysis of variance, one way, which is the simple one, I think we're good on this one. Yeah. And if anything, we'll go further. Basically,